Given the function f from r squared to r, where the f of x and y is equal to x times y squared divided by x squared plus y squared if x and y are different from 0, 0, and it is 0 if x and y are equal 0, 0, whereas to calculate the directional derivatives and partial derivatives in 0, 0. Let's go first with the directional derivatives. So, given a vector v with coordinates v sub 1 and v sub 2, that will give us a direction, and it has to be different from 0, 0. The directional derivative of the function f in 0, 0 is, by definition, it is the limit when t approaches to 0 of f of 0, 0 plus t times the vector we are calculating in the derivative, that is v sub 1 and v sub 2, minus f of 0, 0 divided by t. This would be equal to, inside here we have 0, 0 plus t, the v sub 1, v sub 2. That is the point 0, 0 plus t times the vector v, and as by definition of the limit t approaches to 0, it is very close to 0. This second term right here is going to be 0. So the formula would be like f of, how much is 0, 0 plus t times v1 and v2? That would be the same as t times v1 comma t times v2 minus f of 0, 0. And as when we are in 0, 0 a function is 0, let's write a 0 here, divided by t, of course. Now f of t times v1 and t times v2, this is 2, this is x and this is y. We know that v sub 1 and v sub 2 is different from 0, 0, and t is very, very close to 0, but it's not exactly 0. So when we calculate a limit, the value of the t approaches to is very, very close to it, but it's not, as I said, exactly the number. So if the vectors v1 and v2 were 0, 0, there would be no direction, so they have to be different from 0, 0. So this numerator, the f of tv1 comma tv2, has to be different from 0, 0, because t is not exactly 0 and v1 and v2 are completely different from 0. So for calculating this image, we have to substitute the function. So we would have the limit when t approaches to 0 of the x t times v1, that is the x, times t times v2 square, that is the y, divided by tv1 square plus tv2 square, divided by t. So this would be the limit when t approaches to 0 of, on the numerator we would have t times v1 times t square times v square, v2 square of course, and the denominator would be t square v1 square plus t square times v2 square, and the denominator of it, that is t. So operating this, we have to divide this, and this is the same as on the numerator we have t times t squared, that is t cubed, times v1 and v2 squared, here we go, and the denominator would be t squared v1 squared plus t squared v2 squared divided by t divided by 1, of course, that's obvious. So this limit would be the limit when t approaches to 0 of a cross multiplication, that is t cubed times v1 times v2 squared, and the denominator would be t times t squared v1 squared plus t squared times v2 squared equal to the limit when t approaches to 0 of t cubed times v1 times v2 squared divided by, we can take the t squared out of the parentheses as a common factor, so we will have t times t squared, that is t cubed times v1 squared plus v2 squared. We can simplify it crossing out both of the t's, so we would have the limit when t approaches to 0 of v1 times v2 squared divided by v1 squared plus v2 squared. But this, when t approaches to 0, what does this fraction here approaches to? Because v1 and v2 does not depend of t, so the final result of the limit is v1 times v2 squared divided by v1 squared plus v2 squared. So for calculating the directional derivative in 0, 0, we have in any point we just have to substitute the point or the vector in v1 and v2. Now let's calculate the partial derivatives of x and y. This derivative is just directional derivative. In for x it would be a directional derivative of 1 and 0 in 0, 0, and the partial derivative of y would be the directional derivative of 0, 1 in 0, 0. So this, we would have derivative from x is 1 times 0 squared divided by 1 squared plus 0 squared. This is equal to 0 divided by 1, and that is equal 0. The partial derivative of y in 0, 0 is 0 times 1 squared divided by 0 squared plus 1. That is just derivating from y. That would be v2, and we would have 0 divided by 1, and that is equal 0. We can see that both of the partial derivatives are equal 0, and this right here would be the directional derivative.